Okay, my sweet potatoes. The first thing I would like everyone to do is to recognize and remember, while we're closing up all of our Chromebooks, please, that big numbers, coefficients, and little numbers are different, right? What we do with the big numbers, remember the rule was, we multiply the big, and then we're going to add and subtract the little. So before we start this problem, I would like you guys all to take care of those two big numbers in your down here. So we're going to rewrite this problem, and the first thing we're going to do is take care of the big numbers. So go ahead and do that. You got a new line underneath. I love that. So off to the side somewhere, you got a new line. You're going to start always by taking care of your coefficients. If there had been a 2 down here and there isn't, you could have canceled those right away and then just had the 3. But there isn't. So you know the first thing you're going to do is make that into a 6. We handle the coefficients separately. They're their own thing. Okay. The next thing I do, now I want to be really honest. You can start adding, you can start subtracting. There's lots of ways to do this. But for me, I don't love the negative exponents. So I am going to go through this problem and put everyone where they belong. Lots of teachers don't do that. I do. So rewrite this problem, but put everyone where they belong. If they belong upstairs, leave them upstairs. If they have a negative, put them in the right place and make them turn happy, right? Do that now, right? I'll give you a first hint. This x to the 4/3 is happy, but this y to the 2/3 is not, so he comes down. Please do the rest of go all the way through the problem that way. Ben is doing this. Ben is doing this. Still Ben. There you go. Yeah. If they're positive, they're happy. They're good, right? And it doesn't matter if they're negative down or negative up. They're unhappy. Put them in the up place, and they turn happy. So if there had been a -1 down here, you would have moved it up. It would have turned happy. Negative just has to do with location. Nope. Negative says wherever I am, I don't like it there. And then the minute he goes upstairs, his attitude is better. Talk to me, Savannah. No. These guys, so really what we're doing is 2, 3 times x times y times 2 times y times y. We're times them at all. So that's why we can take care of these guys. Because watch this. If you have 2 times 5 times 8 times 7, the smartest way to do this is to start with those guys and then times, right? Yeah. Yes, they are all technically separate.
Whatever those two numbers are, do we always multiply them to each other?
Yeah, because they're just big numbers. They're just coefficients. They're just regular ass big numbers, right? So watch this. If we had 5x times 3y, in real life we'd make it 15xy. Multiply the big, add the little.
What if there was a
5 where?
Like where you said there was a 2, but instead of like a 5 and it does a 6.
Living his best life down there. Right.
So now we do like.
Okay, here we go. So I've gotten rid of the 2 and the 3. The y is downstairs. Ooh, that y. Ooh, he's happier downstairs. That y, perfectly happy upstairs. And if you want to put some hidden exponents on, you can. Hold on, I'm going to finish. X to the 1/4, and I'm not ignoring you completely, just a little bit. Okay, am I okay? Talk to me.
So you don't multiply the top, like you don't multiply together.
You are multiplying everything together. 2, 3 times x times y times 2 times y times y. They just don't keep putting the dots in. We are truly multiplying everything together, right? And here's the rule in life. Check this out. I just did this with Natalie. 2 times 8, I did it with Savannah, times 7 times 5. If I wanted to do that very quickly, what would be the best 2 numbers to multiply first before I do this? Why not 2 times 5? What is 2 times 5? 10, and then it's just going to be 560. Do you see what I'm saying? You're allowed when you multiply to move things around, right? Do what makes sense. Take care of that 2 and the 3 very first, right? Coefficients, we take care of them. Okay, is everybody okay if I do this now? Watch what I'm going to do. I'm going to minimize this so it's not confusing to us. Is everybody cool? Goodbye, problem. Are we good to hear? Okay, now you have lots of options here. You can take care of your X's first. You can take care of your Y's first. You can do all sorts of things, but, and I don't care. I'm just going to teach you what I do. So I want you to look at this really quickly. I see something in this problem that I can eliminate right away. I got a little cancel action. I feel like Mila sees it. I think David sees it. You're going to see it in just a second. Talk to your neighbor. Do you see something that we can cancel before David says it really fast? Oh, okay, that was Mila. Just shout that out. Mila got it. Cancel the Y. Cancel the Y. Do you see what I'm saying? I can get rid of those guys. That just makes my problem not so scary, right? Okay, so the next thing I'm going to do is this. If you are okay with this, just so I get better at it, I'm going to put the X's closer to each other and the Y's closer to each other. You don't have to do this step, but I'm going to do it. So that's 2/3, that's 2/3, that's 2/3. I got to try to remember that. Let's see if I can make him move. Oh, come here. Nope. Oh, look at that. That was cool. Is everybody cool with what I just did there? Because our next piece of this is to deal with the X's and figure out how many of them I really have. And my next thing is to deal with the Y's and figure out how many I really have. Here's why you don't like these. The same way you hated 5th grade math. Because we've got to add and subtract some baby fractions. They're very small, but we will need to add and subtract. Here's when we know when we do it. Top to bottom, subtract. Same level, add. But I need a common denominator to do it for the X's. Let's start with the X's. I've got 4/3 on the top and 1/4. I'm going to be subtracting. I need them to have a common denominator. So here's what I'm going to ask you to do with your neighbors, please. Get a common denominator for those two dudes, right? I gotta put them together. We're just going to be doing some subtracting, but I can't, right? I feel like we're sparring on this stuff. You guys, you like these steps. So I heard someone over here say 12 and 12. I'm going to go 3 here. 3, that's 16. Does that look good?
Oh, no.
Are we good?
Yeah.
Okay, so here's the rule. 1 on the top, 1 on the bottom. We subtract, and the answer goes where the bigger guy lives. I have 16 of them up here. I'm going to cancel them with 3 of them down there. So the answer is going to end up living on top because that's where more of them are located. So can you please do 16 12ths, take away 3 12ths, and put your answer up on the top. It's a dumb answer, and that's okay. How does that look? Are we okay? Are we good? Everyone's with me?
Yeah, we're always.
Okay, we got one last letter to deal with, and here's what. Now we need to put those Y's together. Guess what? Same thing. Common denominator, please. Common denominator.
6.
Yes, that's right. Once we've taken all of the exponents away, it goes away. Common denominator for the Y's. David, get our common denominator for the Y's, please. It's a really easy number. 6. Yeah. You know, even middle school, kids think it's played out, right? So, you know, when the middle schoolers won't do it anymore. 6, 6, 4, 3. I love my whiteboard on this. Okay. When I taught Algebra 2, I was mean enough that we did this problem to here, and then we stopped. And I said, good enough, Algebra 2 kids, because taking some of the kids in Algebra 2 to here was damn hard. But you guys are pre-calc, and we know the final rule is this. We cannot have fractions in the denominator. And I have one. So I am going to explain to you something that I explained to a kid in first period. This seemed to help them. So here's what I want you to imagine. You bake a cake for your Spanish class, and it's delicious, and you put it out on the counter. Your dad gets up before you to go to work, and he sees the cake, and he comes in, and he takes a chunk of it and eats it. So now this is the cake. But you can't take that to Spanish like that. So you need to really quickly bake some more cake to fill in this spot to make it a whole cake. I have 7/6 here. I can't have a fraction. I need a whole number down there. I can't take stuff away because I only use negatives, and then we're trapped in the cycle. So the next thing I can do is to give this guy more cake to get him to a whole cake. What is the next number that 6 would go into to make a whole cake? It doesn't go into 8. It doesn't go into 9. It goes into 12. Does that make sense? I need this to be 12/6. He's only 7/6. So I am going to need to give him 5/6 more cake. But the way we do that is like this. Does that make sense? Because I need this to get to 12, right? I need to be a whole number. The next big number that we're going to go into is 12. Because I need it not to be a fraction. So if I give him one more little tiny bit to make it, no, that's not a whole number. 2 more little bits, 3 more little bits. But if I get to 12, because guess how much that is? 12. Does that make sense? And so I'm going to give it to him, and here's the rule.
You can do it today. I'm done.
Yes, 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 yes. Oh my God, so much better. Everyone's getting this. So guess what I have now on the bottom? I'm putting this all together. I got 7 plus 5. That's 12/6, right? Hey, I know what that is. That's 2. That's no longer a fraction. And let's check the answer. Answer says, woo. I don't know why my software puts this in this order. I don't care what order you put it in. Nope. Same exact answer. They just do the X's and Y's in from the X's. And why? Why do they do that? Why? No. 3 times 2, 2 times 3. You know what? It's a glitch in my software, right? Yes. I like it like this. Yes, because I can't just randomly add a floating exponent. I got to give it something to anchor on. Does that make sense? Love that. Wow, nicely done. See what I mean? I got to lay the foundation. Every day we do one more, right? Every day it will get a little easier. Wipe off your board. I am still taping. I have literally like a 10-minute lesson. You will think to yourself, thank God we're heading back to easy stuff. Welcome to easy stuff land.
Yeah, right. This is what you're talking
Okay, so I am taping, so I am going to actually write out the law of exponents. I am not telling any of you to get out paper, because you don't need to for today, because I'm going to write the law of exponents, and you're going to look at it, and when I explain it, you're going to be like, that's the stupidest, easiest thing ever. So here it is. I'm going to write it. Don't talk for a minute. Let me just write this. Okay, we're quiet now. Here we go. I'm gonna highlight this, and again, you're gonna be like, I don't quite get what you're saying. And when I show it to you, you're gonna be like, I can't believe you made us actually think this, because how is this not obvious? So here's what it says. It says, if the bases are the same, then the exponents are the same. Here's what this tells you, and wait till you see it, and you're gonna be like, really? Honest to God, this is what we're doing. Yes. Oh, yeah, I'm sorry about that. Okay, here we go. So here's what it says. I got 3 to the 7th power. Yay. I am going to set it equal to 3 to the x. I am setting 2 things equal to each other that have the same base. And if the bases are the same and they're equal, the exponents have to be the same. Like, genuinely, that's all there is to this. So our job tonight is going to be to solve baby problems. And what we are going to, in essence, be doing is ignoring the bases. Because if the bases are the same, we can ignore them. Now, I want to be really clear for those people going on to calculus or pre-calc in college. Do not ever tell a teacher, oh, you cancel the bases. We don't do that. We ignore them, right? They don't cancel out. We just get to ignore them, because if they're the same, then we just deal with their exponents. Now, there's a couple of tricks to this. One is the bases have to be the same. And 2 is I can only have one thing on this side and one thing on this side. I can't have like 4 things on this side and one thing on the other. We will have to condense it. So I have one thing on one side with a base, one thing on the other with the same base, and then I ignore the bases, and the math is light. Are you ready? We're going to do 6 of these babies on our whiteboards. Here we go. Verse 1. If you actually have to write this problem down to do it, I will mock you. Thank you. Thank you. I love that. I won't mock you. That was a lie, man. I got to take that back. Colin, did you put 6? Ignore my bases, because they're the same. X plus 2 equals 7. X equals 5. Yay. Here we go. Stepping it up a little bit. Oh, a little bit spicier. I don't have the same base. So guess what? I'm going to take that big guy. I'm going to write it, drop it down using the base of 5. I'm not going to try to make the 5 into 25. That's too hard. I'm going to take that 25 and say, wait. You can't trick me. I can rewrite you as a 5 to the something. Ignore those bases. adage. Okay? Oh, because I did all the math in my head, moved it to 4 over 6 divided by 2. I'm just lazy. Didn't show them. Okay, lambs, here we go. Now, the first thing I want you to do on this one, I want you to rewrite 9. I want the base. We always try to go to the smaller number as the base. So I got a base of 3. We're going to keep that. We like the smaller number. So can you do me a favor? The first thing I want you to do, keep that, take that 1 over 9. Do me a favor, just make the 9 into 3 to the something, right? So you're just rewriting this baby like this, right? So let's try that again. 2x plus 3, yay, equals 1 over 3 squared. Everyone's feeling that. But guess what? That's not one base equaling another. I got a flipping fraction. He's downstairs. I don't want him downstairs. I want him to go upstairs. He's willing to go upstairs, but he's not going to be happy about it. He's going to have a negative attitude. Move that 3 squared upstairs. Because all negative exponents tell us is I'm not in my right place. No, do we get it? How do I move this guy? So I'm asking you, how do I move something from the denominator up to the numerator? Where? Where does the negative go? In front. In front of the exponent. That's what I was looking for. Sorry. Are we good? Everyone feeling it? Natalie, we good? Yeah, you got it. Okay. So we can move stuff now we don't need any more fractions. To be truthful, in some calculus classes and some college pre-calc classes, they will begin to change everything from fractional form to exponential because you can move anything to the numerator by using a negative exponent. Okay, this next one is a little, I love her. I love her. I love her. You are fired. 1 is a magical number because I can turn anything in the universe, maybe put it away. I can turn anything in the universe into 1, or 1 into anything. Watch this. 1, I don't want it to be 1. I want it to be 700. How do I do it? 700 to the 0. 1, I want it to turn into 1,000,000. How do I do it? I put it to the 0. So what I need you to do is give me a new base instead of 1. 7 to the 0. Anything with a 0 is 1, so I can change 1 into anything in the world. 2x minus 4 equals 0. 2x equals 4. X equals 2. Yeah? Okay. The next one is the one that's a little bit spicier. So if you've been talking, I need you to stop for a little bit. Now that's you. Okay. Nice and quiet in the back. Thank you. This is our last spicy one. So here's what. I want you to not think about that we're multiplying this together. I want you to think that we're going to be condensing this down, right? What kids want to do is they want to say, oh, that's 16. And that's not true, right? Because watch this. If we had 2 to the 3rd and we had 2 to the 2nd, we would not make that 4 to the 5th. What you would do is say, oh, wait, that is 2 to the 5th power, right? So don't think on these ones that we're multiplying the big numbers like we did on the other ones. The variables are not mixed in. What I want you to think about instead is condensing this together. And when we do that, when we condense, we add the exponents. So instead of being a 4 over here and a 4 over here, like a 2 over here and a 2 over here, what we're going to do is we're going to condense them with one base with their exponents added up. Are you ready? So what happens here is it's going to be 4, yay, but now we're going to say 2x plus 1x minus 3. Because the rule is one base on one side, one on the other, so we have to condense them. We pull it up? Because when we multiply numbers, we add their exponents, right? It lags behind. So we're keeping the same base, we're just adding their exponents. Could I do that if they had different bases? No. So watch this, Couldn't do it. Right? Gotta have the same base. Okay, here we go. Let's do it. Here's what we got. The math is easy. 3x minus 3 equals 12. 3x equals 15. X equals 5. Okay, we're going to wrap this baby up. We have 2 last ones that are a little spicy. I like them. This is kind of everything we've done in the last 3 slides. Move some stuff upstairs. Do a little condensing. Rewrite that guy. Be careful. It's 25 squared or 5 squared squared, right? Give this one a try. Yes, 5 to the 4th. Ladies, Emma did this probably. Yeah, Emma. I love that that's on tape. You know, that Nikita can listen to this and you hear me yelling. Well, stop! Don't say you. Oh my Lord. It really is on tape. Stop it. Stop it. Stop it. 3, yeah, 5 to the negative 3. That's 5 to the 3rd. You up to the top? Yes. Lovely. Yeah, I think it's 7.2. I'm sorry, 3.2, 3.5. You know what? I was just shouting numbers out there. Here we go. You guys ready? Everybody with me? I am stealing from my girl Ella up here. Here's what she did. She brought that 5 up. Love that. She also said, hey, that's 5 squared squared. So then she said, oh, wait, I can condense those. Love that. And I can say, when I raise a power to a power, I multiply. And now I got 1 on one side, 1 on the other. Now I get to ignore them. So it really is like not super, the math, this part is super easy, right? Okay, here we go. Last one, best one.
Hold on.
Here's a couple hints on this. When we raise powers to powers, we multiply. So don't get in your head about this. Don't make it some weird thing. It's just 2x times 3. It's just 6x. Right? And on that one, that's 4 squared. And then do a little bit of baby distribution. Here's a little thing. Here's a little thing. This will help you. You'll like that. You'll like that. Baby distribution. I'm gonna let you look at that. If you're still with me at home and listening, too bad, do it on your own. Bye. I'm gonna stop taking. I know that's funny. Videos.